Hello, everyone, and welcome to the virtual joint ICCCBE CIBW 78 conference. And welcome. And right now we have three presenters for the first part of the session dealing with artificial intelligence applied to the built environment. Our first presenter is Zhifang Pan. I don't know if I speak it rightly. And the paper title will be Classification of the Requirement Sentences of the US DOT Standard Specification using Deep Learning Algorithms. So please, Zhifang.
Good morning, Europe, and good afternoon, Asia. Hello, my name is Zhifang Pan. I'm a PhD student at Yonsei University in Seoul, Korea. Today, I will talk about how to automatically detect requirement-related sentences from a large document using deep learning. A big document or a specification usually consists of over thousands of pages and tens of thousands of sentences. So it is very time-consuming, error-prone, and challenging to identify all the requirements from a massive number of sentences. Unsparingly, some errors, omissions, or misinterpretations of contractual requirements is the top reason for the construction dispute both in South Korea and in the US, according to the Korean Arbitration Report, and ArcGIS, the Global Construction Dispute Report. However, with the recent advancement of deep learning, the accuracy of natural language processing has been exponentially improved these days. To automatically analyze documents using deep learning, the text data needs to be transformed into a machine-readable format first. This transformation process is referred to as a word embedding. In a deep learning-based text classification, since the representation of text data depends on the embedding method, it is very challenging to know which combination of an embedding method and a deep neural network will work best. So the research goal is this study is to find the best combination of word embedding method and a deep neural network. And finally, we aim to automatically classify the construction requirements from a large contract document. To achieve the goal, this study compares several combinations of popular embedding methods and deep neural networks. For the word embedding, we used word-to-back, GLOBE, and a self-trained model. For the text classification model, we used the CNN, LSTM, and the combination of the CNN and LSTM. The self-trained embedding method is to train an embedding layer only using our own dataset. It is good for identifying domain-specific terms. On the other hand, when we used both word-to-back and GLOBE pre-trained by a large dataset, the embedding layer did not train. Just we can use the embedding matrix as an input. Next slide, please. Okay. In a three deep neural network, CNN is great for short-distance feature extractor, whereas LSTM is better for long-distance dependencies. The combination model can capture both local and global features. And here is the research framework, beginning with the data preparation, labeling, and pre-processing. Then the data set was vectorized using three word embedding methods and divided into training and test data sets. This study deployed a total 9 cases. Next slide, please. So this study used a multi-layer perceptron, which is the simplest neural network, as the baseline model. It has only one hidden layer and 2 dropout layers to prevent overfitting. For the baseline model, 87.8% was the highest F1 score using self-trained model. The first step is data collection. This study used the standard specification of the US Department of Transportation. The original PDF format document was converted into a spreadsheet using MS Excel by deleting non-plain text such as figures or tables. And the next step is data labeling. A couple of previous studies by Merida 2080 and Lu 2090 have identified specific words frequently appear in a regulatory or requirement sentences. For example, modality verbs such as must, shall, may were used to denoting obligation. Based on it, we added more terms that signify prohibition, actions, and constraints indicating requirement sentences. For example, if a sentence includes a verb notify, it might be associated with notification requirements. After labeling, during the first cycle of the pre-processing, we used the 4 stop words provided by the NLTK library. Through the several cycle of iterations, some words were added or deleted from the default stop words, and the bottom left table shows the modified stop words. For the training and validation, the K4 cross-validation was used. This study said the K4 means we divided the dataset into 4 groups and conducted 4 validations by setting one of the 4 subgroups as intern. Initially, all models showed very low accuracy, even below 50% due to overfitting. Data augmentation and pre-processing are fundamental solutions, but they are too time-consuming. Instead, we increase the training epoch or batch size or added more dropout layers, which are more simple and fast way to solve it. Here are the results after fixing the overfitting. The dot shows the training accuracy, and the line shows the validation accuracy. If the 2 trends show similar patterns, we can say that they don't have any overfitting. So as you can see, all graphs show the similar patterns. For evaluation in test, we use the F1 score. And finally, we found the combination of CNN and Word2Vec showed the highest F1 score of 92.9%. Nevertheless, the differences between the test results were very minor. And next slide, please. So still many future works remains to improve my research. First, I will collect more data and try to improve the pre-processing and the current labeling rules to determine the construction requirements. Also, lastly, we need to check how the performance varies when we use the latest algorithms such as Elmo and BERT. Thank you for your attention.
Thank you, Hai-Han.
Thank you.
And our next presenter, it will be very fast, okay, people? Our next presenter is Peter Wong, right?
Yes. Yeah.
The paper title would be in, I think I could leave you to present the title of your paper to be faster, okay?
Okay,
You're
sure.
welcome, Peter. Good
Okay.
presentation.
Okay. So will you share the screen for me or?
Okay. Just a
Okay, sure. Okay. So hello everyone. So hope everyone can hear me. So this is Peter Wong from the Hong Kong University of Science and Technology, and I'm presenting my work about enriched and discriminative human features for the person re-identification based on explainable behaviors of convolutional neural networks. So basically, it's about deep learning explanation work. So next, please. Okay, thank you, Chair. So as a motivating example, so this is our campus, HUST. So between 2 points, there may be 2 routes. One is about more stairs, but with cover, and one is wide open, but without cover to protect you from weather. So if we can know how many people walking each route, we can know the analytics and to improve the design possibly. And the motivation is to use computer vision and deep learning because as we know, CCTV now is commonly adopted and we can recognize the flow statistics like tracking the trajectories in the region. And CNN, convolutional neural network, is particularly useful, and with deep learning is particularly powerful for that. And a particular problem is about person re-identification, that we have multiple cameras and how we can recognize the same person appearing in different cameras. That is the question we are addressing. And basically, it is to extract some features and do the identity mapping, so can draw the trajectory of each person and then allow the flow analytics. So, but there are two gaps in the current research. One is about the challenging conditions for doing the feature extraction. Like for this different person may have very similar appearance, so or different occlusion or pose variation that we need to have very robust features. And currently, CNN is not very explainable. So that's why we propose a methodology to analyze the baseline models. And particularly, we use some feature visualization technique to do that. And after the analysis, we can explain what design or what tricks we should add to that and to give a better CNN model. So particularly, we use two baseline as the reference. One is the WestNet, which is commonly adopted for different tasks. One is specific to VID, which is OSNet, one of the state-of-the-art at the time we do the work. And but the question is, we have two baseline here. How do we interpret their feature extraction behaviors? What they are doing on the images? So particularly, we use the feature extraction visualization techniques, and you can see here we can visualize where on the image that the model is focusing. For example, for face recognition, it is focusing on the maybe nose of the person. For image classification, it is focusing on the real object, the target object. So if we adopt it into the human images, we can see that WestNet, it just have a very coarse attention over the person, but OSNet has a very tiny attention to like very discriminative, like the shoes of the person or the head of the person. That can allow a good VID. But there are some different behavior of the OSNet that it is too sensitive to the some very tiny parts. Let's say the logo of the clothes, or just the very eye-catching color of the person, and then surprisingly, it gives the failure result here. So that gives the motivation to give a better model, and we study this technique called batch drop block. So basically, it is during the training stage, it can erase part of the image, part of the feature maps, and then allow the model to, force the model to focus on different parts. So the effect is that gradually it would enrich the attention of the model, and then give the better result. So that is the model we propose, combining OSNet plus this BDB technique, and then give enriched and discriminative features. So basically, we have some parameters. We erase 1/3 of the feature map, and then allow the model to focus on different regions. And for the evaluation, we use a benchmark data set collecting from University US, and it has different cameras, including 8. And the same person, you can see their very diverse appearance. So that can validate our model's robustness during the occlusion and the post variation. And for the evaluation, we use the standard VID metrics, the rank 1 accuracy, and the mean average precision. But more we add is about it qualitatively. We analyze the feature maps, the model extract, and we aim to have a flexible, widespread features on the image. So that is, you can see the result here. Our proposed model have the better result performance than the baseline models. And we can, from this table, we can tell our proposed model have better result than the baseline model. But you can see, you may wonder how the model do, what the model does to do the better result. So that is the value of the next slide, the qualitative result. So can I have the next slide, Chair? Okay, thank you. So you can see the top row is about the baseline OSNet. So originally, as we said, the OSNet may be too concentrated to some very small or eye-catching region, like just the clothing color of the gentleman, but all the way it recognizes another lady as the same person, which is not good. And yeah, similar patterns here. But our proposed one, OSNet plus BDB, you can see the result improvement. For the same person, it can attend to different parts of the images. So the features will be more redundant, and even the pose is different, we can still identify the same person. And for another comparison, we can, for this OSNet variant 1, you can see the model extract mainly on the head and shoes. You can see here it's separate to the two edges. So for yeah, different images, it is like the similar pattern. So we think that the model has ignored the middle, the main body part, which may be very useful to provide features. So that's why another variant, the OSNet BDB 2, it is really feasible to widespread to different regions, so which gives the best result. So to summarize, we kind of adopt a feature visualization technique to explain the failure case of baseline models. And based on the analysis, we can propose a more robust model, and which can facilitate the flow analytics. So yeah, maybe some limitations is that our model is only validated in one benchmark data set. Maybe in the future, we can evaluate in other data sets for more generic comparison. And we only evaluate a single strategy to do the drop block. Maybe there could be some adaptive or even deformable Dropbox that could be better in the future. So yeah, that's our work. Thank you very much.
Thank you, Peter, for your presentation.
Thank you.
We'll not have Daniel presenting today, so I think it would be good to go to the next presenter, Zhifang Pan, please. I don't know if I said your name right.
Yeah,
Zhifang
it's right.
Pan, right? Okay.
Yeah.
You're welcome. Just to remind all you, the presentation goes automatically, right? That is 20 seconds for each slide. Okay? We are not changing the slides. Okay, Zhifang, it's your presentation. Thank you.
Okay, hello everyone. My name is Zhifang Pan, a PhD student from Shanghai Jiao Tong University, and I'm going to briefly introduce our research work. We propose a deep learning-based method for surface scratch detection of monolithic glass panel. And first, I would like to acknowledge my co-authors. And as an overview, I will briefly take you through these following 5 parts: the introduction, the methodology, followed by the experiment, the discussion, and finally, we have the conclusions and some future works we will conduct. Glass has increasingly used as a building material for decades due to its superior mechanical strength. However, the surface scratch can be generated in glass production and debris impact from sandstorm or typhoon in surface stage, and leading to the strength degradation of the glass. Next slide, please. And such damage can cause the glass breakage and result in worse failure of the glass facade. So it can be a life-threatening event to human. And we need to conduct the regular inspection to maintain the serviceability of glass panel before it fails. Next slide, please. Recently, deep learning has developed in a rapid pace and has rendered the possibility to conduct the object classification, detection, and as well as the pixel level instance segmentation. So to this end, we aim to use the deep learning-based approach for surface scratch detection of glass panel. Next, please. In order to achieve the goal, we construct a typical instance segmentation pipeline called the mask and region-based convolutional neural network. There are basically 2 stages. First, the convolutional backbone extracted the desired features, and the region proposal network can generate bounding box proposal for object detection. And then followed by the ROI align to produce the fixed size feature map. And finally, the head of the network architecture is a stack of fully connected layers or fully convolutional layers to achieve the goal of classification, regression, and segmentation tasks respectively. Loss function represents the gap between the prediction value and the ground truth during the process of model training. And in the mass RCNN architecture, the loss value is the combination of 3 independent tasks: classification, detection, and segmentation respectively. This is the workflow of our system. Our system is built based on the trained model using the history, defect images, and annotations as a preliminary works. So when the inspection images are collected, the location and the counter of the scratch can then be outputted. Collecting high-quality images is the key for our work. In practice, we use a microscopic camera to magnify and precisely capture the mesoscale surface scratch. And once the camera finishes scanning, the images can then be transferred to the PC immediately for further processing. Next, please. In the next step, a number of high-quality images are selected to build up our image dataset. We use the VGG image annotator app to annotate the ground truth data in polygon shape. And here shows an example of a single scratch annotation. Training is an end-to-end process with transfer learning technique to reduce the computational cost. Our model is pre-trained on the COCO dataset to obtain the initial parameters. And the loss curve of training and validation, you can see there's some overfitting after 200 epochs. Test is performed to evaluate the performance of a model. The precision, recall, the missing rates, and the false rate are the indicators calculated based on the truth condition table of prediction. Next, please. Since the precision and recall value all have an inverse relationship, a commonly used metric is the mean average precision in the detection task. The mean average precision computes the average precision value for the recall value over 0 to 1, and as shown in the following equation. And there are totally 72 images in the test data set collecting from several new test samples using the same device. And we can see that most scratches are correctly detected with a low missing rate and the false rate. And here shows the detection result with a bounding box and a mask overlay on the original image. The counter of the scratches are almost correctly segmented even under the grid line background interference, and showing the robustness of our model on the new test images. And finally, we conduct several extensive research to investigate the effect of various training strategies. We can see that there is no need for increase from 200 to 300 epochs since there's no much MAP increase. And with the data augmentation to increase the number of image data sets, and through the strategy of multi-level trainable layers, the MAP can improve so that we can get a more reliable result. As a conclusion, a deep learning-based approach was proposed for surface scratch detection. It is the first successful attempt for the glass defect detection, and our model achieved satisfactory results. The next step, we need to optimize the model with to reduce the inference speed and to conduct the scratch qualification. And also our result can incorporate with the image-based numerical model for further failure analysis. And that's my presentation, and thank you.
Thank you, Zhifang. Right now, we could have some questions and answers for the three presenters. And we have one question for Haihun, Robert Amor. I don't know if, yes, right. Could you read, Haihun, the question on the screen? You can see it.
Okay, nice to meet you, Robert Amor again. The question is the accuracy seems to be plateauing at around 90%. And is this likely to be the best performance we're going to see? First of all, thank you for asking question. And of course, I don't think so. This result is the best performance because if I input more data, bigger data set and sophisticated process them, maybe the accuracy can be improved. And also, I need to increase of using more deep neural network and more hyperparameters. Yeah, it's also it could be a future my future works. Thank you.
Okay, great. I have some questions also. I will ask for Peter about his work. Peter, the feature extraction that you are proposing, I think you didn't mention about if it could be running in real time.
Okay. Okay, so actually for the VID work, the processing speed is not important because the processing speed will bottleneck at the detection stage because you are running with the raw image like 1,000 times 1,000 pixels, which is the bottleneck for the processing. But for the VID alone, it is very fast. For my model, it is 1,000 frames per second, 1,000 detection blocks per second. So it is very fast. But for our VID work, we ignore the detection stage. So yeah, we will focus on the subsequent downstream. Yeah.
Okay, great. And your models, because you are right now dealing with just feature extraction, right? But when you put your feature extraction in a tracking algorithm, it helps to predict the path that the pedestrian is taking if he's occluded by a car or a bus or other people. How you could use your feature to better performance in such occasions.
Yes, exactly. That's the exact breakthrough, I would say, from our model because as you may have seen, our model can enrich the attention to different part of the person. That means it can solicit different part features and then into a single like feature factor, etc. So if you have occlusion partially, it can still have redundant feature on remaining visible parts, which can allow maintain the accuracy. So actually, we have seen some examples in our data set and with the car occluding the bottom part, and we can still identify the same person quite well. Yes.
Okay, great. And a question for Zhifang. The results that you presented to us, I think the last images, it seems that the scratches are so visible. Is that you tried to extract the scratches with more simple image processing, and also you have in your database scratches that are less visible than the one you presented to us?
You mean the training images and the test images?
Yeah, I'm wondering if you could use a more I don't know if it is old approach, but if you just pick up the gradient of the image, the scratches are so bright compared to the other parts of the glass. I think maybe just a gradient could find those scratches. Did you try simple processing instead of the neural network? Deep learning?
Yeah, for some of the images, the image processing techniques works, but we also have some like a complex background, which the background is a little bit difficult for us to find, and the features is a little bit difficult for us to extract. So I compare several methods and find that the deep learning based method is the most robust method. Yes.
Okay. And as you mentioned, you need to prepare. I don't know if it is just for this work, but you said you prepare those images. You use a specific camera, and in that case, you are also putting the glass over the same background, the same table. I don't know, and you can control it. Or in the end, you are hoping to pick up glasses installed on the already in the building with different backgrounds. Could you explain
Yeah,
more?
I think for now the techniques we use are sometimes like the experiment lab in the experiment lab, but in the future I think we need to use our method to assist it with the like drones or some other methods to like monitor the condition of the glass facade or some other glass structures. Yeah.
Okay, thank you, Zhifang. We have another question. It's for Haihan.
Yes, I read it. Another follow-up question by Robert Amor asked me that you have an estimate of how high the accuracy needs to rise to be fair. The automated approach for required sentence will perform like a human. Actually, I couldn't find the exact the minimum threshold the machine should be over some value, but there are another example of the legal field, the AI machine called Logix. The Logix, I remember that they performed over 95 or 80%, close to the 100% over the accuracy of the human. So already the highest performance of the AI in the legal field. So it will be it can be applied to our construction field, of course. Yeah, it's another criteria. It's example of the another industry.
Okay, I also have a question for you, Haihan.
Yeah.
The best result comes from the word to fact, right? And in this scenario, you are using just words, or you are using some combination of consecutive words, 2 or 3 consecutive words. You understand that? I don't know if it's automatically, if it could use 2 words that comes always in sequence, and these 2 words becomes a new feature. You are using this second order and third order in your approach?
I use only one word, not a word sequence, but I will adopt the word sequence by trigram, bigram. It's more accurate. I think so.
Okay, great. I think that's it. We have no more questions. I don't know if it's time to call the other participants if they are waiting to enter. We have 2 new presenters here in the room. I'm seeing them. Welcome, Yalong. Welcome, Tsihao. Welcome, Yuchi. We should, okay. Hi, everyone.
Hi, how's it going?
I'm fine, and you?
Good.
It's 3 in the morning here in Brazil, São Paulo, but we are good.
It's 2 a.m. here too, in Texas.
Okay. We have one more presenter here. Let me see. Yes, the 6 is also here. We have 3 from the 5. Okay, perfect. Hello, Yuichi. Is that
Hello.
right? Your name, Yuichi?
Yes.
Okay.
Can you hear I'm speaking?
Yes, clearly. Thank you.
Okay.
Okay, we should wait for 8:44 to start the presentation, right? I don't know if the other presenters will be here, but we still have time. All of you your presentations are with us, right? You uploaded your presentation with us, right?
Yeah, I think so. I sent it to the...
Okay.
Yes.
Okay.
Yeah, me too.
Okay. Thank you. Our first presenter would be Hamal Abdallah, but I think he's not here right now. So when the time came, we will start with Yuichi, okay? 80:44, I think in 5 minutes.
Yes.
And then we'll proceed with Tsihao Wang and Yalong P if the other 2 presenters don't show up, okay?
Sure.
Okay.
Yuichi, if you
Yes.
could turn your camera on, I don't know if you are comfortable with that.
No, yeah. I don't have camera.
Okay. We could put just your presentation. So welcome, and if you could start your presentation right now.
Okay.
Thank you.
May I start? Okay. Thank you for your introduction, Chairperson. My name is Yuichi Yashiro. Today, I'd like to talk about interview-based method for extracting knowledge of skilled worker at construction site using photographs and deep learning. Next slide, please. This is the content. I'll talk about, firstly, background and objective of research, Secondly, problems and their solutions. Thirdly, I will propose new method. Finally, experimental results and conclusions. Next slide, please. At the beginning, background and objective. The situation in the Japanese construction industry is severe. The number of skilled workers have decreased, and many experts are expected to retire in the near future. Thus, there is an urgent need to develop a platform to transfer the knowledge. So next, problems and their solutions. The first problem is that there is a lot of knowledge that exists personally in the brain of the experts. To solve it, we propose a method for efficiently extracting the tacit knowledge by using a functional approach and a semi-structured interview. This figure shows a SEKI model, which is a basic theory of knowledge management. SEKI stands for socialization, externalization, combination, and internalization, and describes the process of translating tacit knowledge into explicit knowledge. In this research, we focused on this process for extracting knowledge. Socialization is to acquire tacit knowledge by sharing them within each individual. And externalization is to create the concept of knowledge and turns into explicit knowledge. Next, let's change the topic. The second problem is the vast amount of past data possessed by experts. Most of them are personally managed in a closed site. To solve it, we propose a method for extracting photographs by using object detection and transfer learning. This shows an overview of a proposed method. Centering on the database, the person-associated files are registered before interview. In particular, for photographs, the object detection with transfer learning is adapted. Photos in computers of the expert can be automatically classified and extracted. And then, during the interview, the questioner and the expert browse the registered information and extract the knowledge by using the functional approach, semi-structured interview, and support system for registering knowledge. By using these methods, the questioner can efficiently and exhaustively extract the knowledge. This figure shows SSD with transfer learning. Best CNN network uses PZ16. Transfer learning is performed using weight data that have been learned in advance in 20 classes of Pascal VOC. Next, please. So we apply the system to special equipment over a nuclear power plant. The number of photos was 882, and 7 equipment were selected. And recognition accuracy was evaluated by the F measure, which is the harmonic mean of the precision and recall. This shows the cross-validation results. F measure was compared with and without transfer learning. Left figure shows the comparison for levels, and right figure shows for datasets. By transfer learning, on average, 70.1% improvement was achieved. And we evaluated the working hours for classification with and without SSD. We tried about 70,000 photographs. In the case of the manual method, it took about over 500 hours, but SSD could reduce it to 38 hours. Next, I will explain about interview method. We use these two methods. First, FA is an approach of thinking by replacing objects and things with functions. And SSI is an interview method to prepare rough questions in advance. Firstly, a basic function is defined and decomposed into key functions, and hypotheses are made to satisfy each key function. And then rough questions are assigned to the corresponding work step. By these methods, the knowledge can be extracted efficiently and exhaustively. This shows a support system for registering knowledge. During interview, the questioner and the expert browse the system and register the knowledge. In this way, the knowledge can be visualized and anyone can easily understand and reuse. This shows the interview situation. One monitor displays the question list and another displays the system. The interview was conducted on 3 works of nuclear power plant. Work A, the interview was conducted without any preparation. Work B, the system was used. Work C, additionally 2 methods were used. This shows the results. We defined 2 evaluation indexes. The first index was time efficiency. The second index was exhaustiveness. Compared with the work A, work C could improve time efficiency by 77.1%, and the exhaustiveness was increased by 2.9 times. As a conclusions, the use of SSD and transfer learning made it possible to automatically classify and extract the huge number of photographs. And transfer learning improved the F measure by 70%, and to classify with high accuracy of 89%. And regarding extracting tacit knowledge, we developed the support system and utilized FA and SSI method. As a result, the time efficiency could be improved by 77%, and the exhaustiveness could be improved by 2.9 times. Thank you for your attention.
Thank you, Yuichi, for your presentation. Right now, I call Zhifang to present his work, please.
Can you hear me?
Yes, clearly.
Yeah, I have uploaded my slides, so.
Okay, just a second.
Okay.
Okay.
Hi everyone, good morning. My name is Hao Wang, and I'm a master student of Department of Civil Engineering and Engineering Mechanics at Columbia University. Today I'll present the paper Building a Next Generation AI Platform for AEC, a Review and a Research Challenge. Next, please. AEC industry now facing the problem of low productivity, which causes low profits, even delay. And 4 main problems are high monitoring costs, low efficient transmission of set information, lack of collaboration and information sharing, and late payment. Next, please. Yeah, to address this problem, we propose an online collaboration platform for interaction between stakeholders in construction projects. We also review related literature and identify existing challenges. And here is the conceptual framework. And firstly, daily construction site data, for example, image, video, or point clouds are collected as input to generate as-built BIM model, while 2D drawings are used for generating as-planned BIM model. And then we can obtain useful set information by comparing these 2 models and analyzing the result. And then with the integration of blockchain technology, the AI-based platform can achieve an immutable and traceable documentation mechanism, and the application of AR technology help develop immersive interaction between real projects and the stakeholders, for example, clients, contractors, and engineers. And then the AI brings a new direction to achieve smart management of progress, safety, and quality in construction projects, especially for remote sites. And blockchain and AI also promote smart contract management, like automated contract execution and payment. Yeah, integrated with AI, unmanned aerial vehicles can achieve automated and real-time site data collection and collection in inaccessible areas. Some challenges are identified like autonomous path planning and navigation, and which involve the problems of obstacle avoidance and localization in indoor environment. Next, please. The automated BIM model generation gives immersive 3D visualization and promotes some automated practice like progress monitoring and cost estimating. The existing challenges include that the building elements are misclassified and that the model is generated incompletely. The application of blockchain makes immutable information transfer, traceable resource management, and automated contract management possible. However, the slow adoption from industry and the lack of specialists are main challenges, as well as the information redundancy during the storage. An AR-based visualization helps achieve remote site inspection and monitoring and assist working on construction tasks and design, yet it is still facing the problem of partial maze of rich BIM information, registration of virtual components, and connectivity with different types of data. And AI-based progress management helps achieve automated real-time and remote progress monitoring. The main challenges involve the error of registration, the difficulty in evaluating certain tasks, like the progress of concrete setting and hardening, as well as the recognition on fine tasks. And for safety, main applications are PPE, unsafe behavior, and hazardous area detection. More attention is paid in detection under various visual conditions and generalization ability. Besides, how to understand the rationale behind the unsafe behavior of workers to avoid the accident. AI-based quality management involves automated defect detection and remote inspection. Similarly, various visual conditions, poor generalization ability, lack of performance criteria are main challenges. Besides, it's difficult to detect small defects and defects that are not visible. Yeah, next, please. Yeah, for contracts, the main application is automated contract execution. However, it lacks tools or templates that enable non-blockchain specialists to edit and legal regulation. Moreover, how to handle unexpected contract change and privacy for special contract condition is very important. So the next generation AI platform gave a vision of automated and smart construction management, while there are still some challenges. The future direction involves solving existing technical problems, design an actual platform, generate related regulation, and adopt advanced techniques widely. So that's all for my presentation. Thank you.
Thank you, Hao-Wan.
Yes, thank you.
Our last presenter would be Yalong P, right?
Yeah, yes, you're right. Thank you.
We are loading your presentation. Just a second.
Sounds good. All right, so my name is Yalong P from Texas A&M University. Today I'm gonna present my paper titled Deep Neural Network for Drone View Localization and Mapping Without GPS Signals. GIS data is very important in a lot of industries, and there are mainly 3 ways to collect the GIS data: ground survey, satellite imagery, and unmanned aerial vehicle, which called UAVs or drones. But drones have the disadvantage of reliance on GPS data and the short battery life. So we did this research on GPS-free mapping from UAVs to be used in severe weather indoor facilities. And when we crowdsource the data collection, the users may not be able to provide the GPS data. That's why we did this research. We first use a convolutional neural network. So this is showing a typical structure of CNN On the left, we have the input, many frames. On the right, we have numbers. And in between, we have different layers. In different layers, we have different size of kernels with weights. And those weights will extract features such as pattern, color, or shape to ultimately produce the class, the location of the object of interest, such as person. And after we got all the information from the perspective view, we want to map everything on the orthogonal view using the homography transformation, which is calculated on the math on the left. So any given point x5 and y5 on the right can be projected from perspective view to an orthogonal view. We also did a literature review on what scenarios we can apply this GPS-free mapping. The domains include disaster management, agriculture, forestry, marine system, construction management, transportation, urban planning, and military defense. They all have their unique reference points to support homography transformation. And we did 2 experiments. For example, experiment 1, we have the same event, a person walking on the grass, but we have 2 different drones recording 2 different videos from perspective view and orthogonal view, PV1, OV1, and the same for experiment 2. So we have 2 approaches. The first one is called projection based on reference object coordinates. We train a model P on PV1, and then we map everything on the orthogonal map, and then compare the mapped position and the recorded position to measure the error. The second approach is called projection based on reference object size. So in this case, we do not have the location of the reference points. In this case, they are cones. We don't have the position, but we have the size of the cones, and then we can map a local coordinate system, and then we map the position of the person. So after training on the collected data, we have model P achieving 97% MAP, and the model O can achieve 48% mean average precision. And the goal is to integrate those 2 models. In PROC, as I mentioned earlier, on the top left, we have the input. This is the only input, and we have the detections. And based on the transformation, we pick the bottom center point of each box representing the location, and we map everything on the top right. And then we measure the distance between the ground truth and the projection on the bottom left. And the bottom right graph is showing the difference between the ground truth and the projection in inch for each frame. This is a PROS, meaning you follow the same procedure as PROC. So after measuring the average projection error, we have around 12-inch error, which is around 4% of the study area. And also we try to remove the outlier detections at k is equal to 2 and 3. K is a parameter that we use to remove. When k is equal to 2, PROS outperforms PROC by 2 inches. When k is equal to 3, PROS also outperforms PROC. And this graph is showing all the error distribution among all the frames that we observed. And we are also aware that the drones will move, right? So we did object tracking to keep track which cones are which. And then we use the cones, the detected cones, as reference points to map the person's location when the UAV is moving around. This is the example of we applying this mapping technique in a disaster scenario. We have the input, and by updating all the reference points along the way, we can map the flood area in square meters. Thank you. That's my presentation. Thanks for listening.
Thank you, Yalong.
Thank you.
I think all presenters already finished. We don't have the two other ones, so we are starting the question and answer sessions. I have a question for Yuichi. You are hearing?
Yes.
I don't know if you are familiar with BIM, the digital models. You think it could be a better piece of information to instead of images to extract that kind of knowledge that you are trying to do? If all the information, the construction information, was put, experts created the BIM models, and based on that models, other people younger could learn more from that kind of information. Did you understand about it?
So sorry, could you say that again?
Yes, you are worried about the extract knowledge from experienced workers, right?
Yes.
And you extracted this knowledge from using interviews, and you propose a different tool to help in extracting that knowledge. And also you showed us how to use images to extract this information. If you have, instead of images and interviews, if you have digital models, BIM, building information modeling of a building, let us say, you think it would be a better piece of information to extract knowledge if you think about it, or in your scenario, BIM is not being used and you are not worried about it? If you could tell us.
So during interview, we use the image expert hub, and other information is used, documents and movie and BIM model, and all information is used during interview. So, and all information registered to this system, and during interview, expert browse this information. So, is it okay?
Okay, no, it's okay. You could tell us also if the workers that you are more used to, how they are comfortable using different kinds of technology, because the construction sector is, although we are talking here about AI in building environment, the most of the people working in this field don't know or are not comfortable with that kind of technology. You could tell us a bit more about it, that you could find in your interviews, your knowledge. You are from Japan, right? How it is common.
Right. What? Sorry, could you say that again? Sorry.
Yes, about the technology. How these old workers are comfortable or not with this different computational technology.
Yes, yes.
Yeah, they are okay using image processing, AI algorithms, they are used to it, or it's not common?
Now AI technology is not common for construction site in Japan. So we are trying to adapt it now. And so there's a many problem on construction site because digital technology is not adapted. So now we are trying some various technology, for example AI. So for future, we want to extract photographs and documents as many information automatically extracted from construction site. Okay.
Okay, thank you, Yuichi.
Thank you.
And Hawan, you presented a framework, right? It's a lot of technologies in your framework. Did you consider also introducing big data? Because I see that the input information is very varied, right? You are talking about autonomous vehicles gathering information. There is image, point clouds, and eventually digital model. How to deal with that many kinds of digital data? Did you consider putting the big data infrastructure to deal with this variety?
Yeah, actually, for the set data, like the image, the photos collected by the still camera or some mobile devices, this kind of data, yeah, it actually can be used. Can use big data infrastructure, big data, some applications to collect and store data, and then we can use this data to our framework. Also, I think the cloud service is also a alternative option to apply in our framework. Yeah, we'll reveal more literature about it later. Yeah.
Okay, and you are doing a PhD?
No, I'm a master student.
Okay, and your work is around this framework, or you intend to implement some pieces of it to make it work? You do a practical work or just this theoretical work?
Right now for this paper, we just present a conceptual framework and do some literature review for that. And currently, we are making a prototype for such a platform. Yeah.
Okay, thank you, Howard.
Yeah, you're welcome.
I have a question also for Yalong. You have the intention to do this mapping, right? Localization and mapping, something like that. I think it is this map is feature specific. You need to find some predefined marks in the image, and based on that, you could map the environment geometrically, I think, because you showed us in the end on disaster mapping. How it could go to the next level, or if you could use, I don't know, in the disaster scenario, which mark did you use? Could you explain more how we could move from cones to more naturally found features to do this kind of map, please?
Yeah, thanks. Thanks for the question. The paper I presented is actually one part of my dissertation, and I graduated already. So the idea is to use the pre-existing map, the housing map. For example, in a neighborhood, we have the housing map from Google Map or other dataset, and then we do need some manual input for the initial 4 reference points, and then we have object tracking, so we can map all the other houses and then compare them with the ground truth and pick the best mapped houses, and use those to serve as a reference point for homographic transformation. And then, for example, flood, for example, cars or people can be mapped without GPS.
Oh, great. Yeah, it makes a lot of sense right now. Thank you. Yeah, great approach. I think it's a good solution because you could try to integrate the IMU of your drone, and maybe based on that try to track and map things. But with human input, just the beginning and I start map, I think it's a good solution. And for us, this kind of information is available, so it's good to use that.
Yeah. And also this can enable what is called simultaneous localization and mapping, which will be very helpful for robots.
Yes.
Maybe we need a higher angle the camera to do the transformation, but it's doable too.
And how, I don't know if you tried it, but how many marks do you need, or how many could your algorithm handle if you put a lot of marks at the same time and your algorithm is tracking all and it's moving? Did you express it, your implementation?
Yeah, I tested. So you only need 4, but you can have more. When you have more than 4, 5, 6, you can filter them out by the threshold produced by the machine learning algorithm. Generally, the higher the threshold is, the confidence or the probability is, the better quality the detection is. So we just go for the top 4.
Okay, great. So I think that is it. We don't have more questions. I would like to thank you all presenters, Yalong, Yashiro, and Hao. And this is the end of the first section of our conference. Thank you all.